Hi everyone and welcome to the sixth lecture. So before going further, let's recap what we have seen so far. So the three building blocks of this proposition to reduce the complexity of machine learning are three basic concepts. The first one is the symbol, and the second one is a learning device, and the third one is learnable properties. So with these three concepts, we can go forward and combine them with the control of mathematical operations to create more complex architectures to solve more complex goals or tasks. So in the previous lecture, I have done another analogy of the scale dot product attention and do an approximation of how we perceive things in the natural world. So I have presented the eyes with learning devices. So we have two learning devices, and the goal of these eyes or the learning devices is to provide how similar the symbol seen with different eyes, and also another learning device, which is the brain, that will create a brain activity and uses the information from the eyes to create a perception of that symbol. So we can consider this as another analogy of the key query value, and also you can do other analogies if you want. So now let's go further, a level further. So in the previous parts, we deal just with simple symbol, one symbol, but this symbol is not always seen independently of a context. So in today's lecture, we are going to talk about a context. So what is a context? A context is nothing but a combination of symbols to create a meaningful sentence. Let's say a sentence is just a combination of symbols in the case of natural language processing. But a symbol could be an image, and image composition could lead to a scene that has meaning, or an audio, or actions, or a set of actions could be as symbols as well. So a symbol or a combination of symbols is the context. So the context is a combination of symbols with transformation applied to them, and they have a meaning to be understood or to be learned. So when learning devices see that context, they will create now a perception of this combination of symbols or this context instead of one symbol. So the perception of a context is different from the perception of one symbol. So with the same analogy, let's see how we can break down this perception with the learning devices of the eye and the brain, just to give an approximation or another analogy of how to see and understand the transformer architecture. So let's see the first context. That may mean a man protecting itself from or himself from the rain. So we don't know yet what is the real meaning of this context. So the reason of the story that I introduced in the second lecture is to make sense and communicate with these symbols. But let's break down this. We have 1, 2, 3, 4 symbols. So the symbol at index 7, which is this one, and the symbol at index 6, which is the cloud, as we presented in the symbol lecture. And we apply some transformation to it, spatial transformation, the position, we add position to it. So with this context here, this set or list of symbols is seen with the learning devices, they will break down it to each symbol independently and try to create a similarity map. So how similar a symbol to each other in that context. So for the moment, the eyes or the learning device's eyes should give a high degree of or should learn to give a high degree of similarity if those symbols in the real world represent the same thing. And there is maybe some similarities between the other symbols. For example, there may be a similarity with that and that because they have approximately the same shape, but since we don't have a goal yet, we could do our best effort to present a similarity according to the examples that we will see in the datasets. So these learning devices will provide a similarity map. It's like a matrix of maps of similarities, and also the eyes or the learning devices, they will try to scan these symbols in order to make sense of them. So they will try to learn how to focus on these symbols in that context. And also that focus map, it's a learnable thing we need to learn in order to achieve a goal. And also we need to control how we can focus on these symbols. So this is an optional mask we can apply to the learnable weights of the attention or the focus map. And also these learning devices have the capacity to tell us how the properties of a symbol is similar to another symbol or the properties of another symbol. And with that, also this context will create an activity in our brain. And we could use this activity in our brain and the focus map and also the matrix of similarities to create a perception now of the context. And in the architecture, this perception is calculated by how similar a symbol to another one or to itself times the plus the similarity to the other. In fact, how similar the properties of a symbol to itself and to the others, and we do a weighted sum of the similarity and the properties of the symbols, and then we can apply an optional learnable mask or learnable weights for the focus with a mask if we want to control the attention or the focus. So this is how we can see the architecture of the contextual perception. So this is a contextual perception or a context perception. So we can do better, and we will try to invent new ways to learn new mechanisms of attention or focus, and also mix that with the learnable properties. So we'll have lots of labs along the way this series, but for the moment we see that no goal so far. So we're just observing and creating a perception. So when I close, for example, my eye, I can recall this perception in my mind. So this is it's not 100% correct analogy, but you can think of that like so. So with that said, see you in the next lecture.